The idea of a space data center usually conjures up a very specific image. We picture a massive, habitable station floating in orbit, humming with endless rows of server racks and maintained by astronauts. That sci-fi concept is a direct reflection of how cloud computing actually works down on Earth. Modern hyperscale data centers require a massive physical footprint, drawing enormous amounts of local power to run, and relying on heavy industrial liquid to keep the hardware from overheating. And all that terrestrial infrastructure shares a strict physical bottleneck. Data speed is inherently limited by fiber optic cables that have to physically snake around mountains, cross oceans, and bounce through regional repeaters. SpaceX is bypassing the massive space station model, opting instead to embed small, distributed compute nodes directly into individual satellites. This shift toward miniaturized hardware allows SpaceX to move the foundational layer of global cloud infrastructure out of vulnerable buildings and directly into the vacuum of space. Placing a server in orbit introduces an extreme environmental constraint: heat. You cannot cool a computer processor with fans in a vacuum because there is no air to carry the thermal energy away. Without a cooling mechanism, the chips would quickly melt. The engineering solution is radiative cooling. The system pulls thermal energy from the central compute module, radiating it into deep space. Older payloads lacked surface area for this, but massive 2-ton Gen 3 satellites provide the thermal headroom required to run continuous compute workloads. To deploy these heavy Gen 3 models in economically viable batches, you need a heavy lift launch vehicle. Starship is designed specifically to clear that launch constraint, lifting dozens of these 2-ton systems at a time. But solving the hardware and launch constraints only produces a flying, isolated hard drive. For these discrete nodes to operate as a cloud, they require a frictionless connective architecture. That connective tissue is Starlink's laser interlink system. These lasers allow thousands of isolated satellites to communicate directly with each other at extremely high speeds. Light travels faster in a perfectly straight line through the vacuum of space than bouncing angularly through terrestrial glass fiber. Connecting those nodes creates a global mesh network, routing high-speed data across the planet while completely bypassing vulnerable ground-based infrastructure. When a user on Earth makes a data request, a radio frequency signal beams it straight up to the nearest overhead satellite. The mesh then instantly transfers that request to an idle compute node, even if that node is physically located thousands of miles away over an ocean. An onboard inference chip processes the task and beams the result right back down. This millisecond routing unifies thousands of separate pieces of hardware into a single, cohesive global supercomputer, operating strictly on the edge of the atmosphere. This creates an immediate strategic advantage: disaster-resilient infrastructure. Because the network features uniform latency from above, the cloud remains fully operational even if regional data centers or terrestrial power grids are destroyed by a hurricane. For military and intelligence applications, an orbital cloud is physically isolated. It is significantly harder to attack or intercept than vulnerable undersea fiber cables. Beyond Earth, Elon Musk has a much longer-term objective for this technology. The Starlink compute project acts as a mandatory prerequisite for Mars colonization. A multi-planetary internet requires robust compute nodes stationed directly in orbit. Future colonies cannot rely on Earth-based processing, and they will lack the established ground infrastructure needed to build massive server farms on the surface. The current Earth-based mesh serves as a live, functional prototype for this future interplanetary communication network. Cloud computing is leaving the building. The most powerful, resilient data centers of the future will be invisible to the naked eye, silently processing global data in the vacuum of space.